I was going to show an example here. There we go. This is the single axis waveform application. Here I'm going to use this channel number 3 as my control. And looking at the setup here, this is my target trace. So I can look at this trace here, and then I can zoom in on that trace. That's my target time waveform that I'm going to output to the shaker. I have some limitations in peak abort and RMS abort here. So if it exceeds those, it'll shut down the test. And if I look at that schedule table, I'm going to start at -6 dB at a lower level, and I'm going to do an offline adaptive control to update my transfer function and update my drive signal. And I'm going to do that back a little bit higher level at -3 dB. Then I'm going to move to full level, and I'm going to do iterative control. And I'm going to do that 3 times. And then eventually I've got this set to go to open loop, and I will replicate that, replay that 10 times. Although I probably will stop it before it gets done, so I don't have to sit there and watch it. But that's an example of a time level table. The system ID, I've already run this. I've already got my system transfer function measured and predicting the full level information. So I can look at my full level channel threshold, my drive signal, and look at that. So that's my drive spectrum. And then my responses, I can look at these different channels in frequency, or I can look at these in time. So this is actually what I'm expecting to see at full level, these predicted time responses based on my measured transfer function from the SysID measurement. So now I go to the control, and I'll arm the system. And you can see up here, my RMS error is going to be shown. We want to watch that. So we're going to start at -6 dB and replay that 1 time to develop my transfer function further than what was done in SysID. So this is kind of another way of doing the system identification. We're going to iterate on that and go to -3 dB. You can watch error here at 13% in frequency of the RMS. And now we move to 3 replays of iterative control. So we can hopefully watch this error go down. You can look at the differences here. So this is the frequency domain. And watch my time domain up here. This is time target and time measured. They look almost on top of each other. You can look at the XY plot here. You can see my error percentage is going down, so that's good. I'm iterating on the transfer function and the time waveform drive signal, so my error starts to decrease as I do more of these iterative controls and updating that drive signal. So now I'm in an open loop with 10 replays, and my error is not going to improve because I'm not changing my transfer function. I'm just replaying the signal over and over. And this will go 10 times if I let it continue, but I'm going to go ahead and stop it. So the idea is that I've generated that drive signal. Now I can play that over and over.